Hello, it's Miss Bettis here, and I am bringing you an instructional video for our first enrichment lesson on solving exponential equations. And I'm going to do a few examples. I'll give you some to practice at the end of the video, and then you can move on to the second video in the series, which is solving logarithmic equations. So, okay, what we have here is 8 to the power of x is equal to 2 to the power of x plus 6. What we need to do in order to solve this equation is we need to have an equation that has the same base, and then we can make the exponents equal. So I want to write 8 as a power of 2. So if you recall, 8 is the same as 2 to the third power. So if you were to type that into a calculator, that would be a value of 8. But our original equation has 8 raised to the x power, so I have to include this x at the end. Okay, so we're going to bring down the rest of the equation. That equals 2 raised to the x plus 6 power. And now what we can do is get rid of our parentheses using our exponent properties. And that's going to be 2 to the 3x power is equal to 2 to the x plus 6 power. Don't forget, when you have a power raised to a power, you have to multiply these together. So now what we have is an equation, same base, and we can make our exponents equal to each other. So that turns into a simple two-step equation. 3x is equal to x plus 6. Okay, now we'll solve it. Bring our variables on the same side, subtract x on both sides, and what we have is 2x is equal to 6, divide by 2, and we have that x is equal to 3. Now with these equations, we are going to want to check our work, so we're going to perform a check on this side. And I'm going to take this value of x equals 3 and plug it into our original equation. So we have 8 to the third power equal to 2 to the 3 plus 6 power. Well, 8 to the third power is 512. And this is 2 to the 9th power. And if I type into my calculator a value of 2 to the 9th power, I end up with 512. Okay, so then this problem, or my solution here, checks out. So the answer is, in fact, x equals 3. All right, let's move to our second example. Slide this up. Our second example is, again, an exponential equation. Here you have a base with the power on it, and you have a value on the right side. Now, in this case, it is not possible for me to write 5 or to write 200 as a power of 5. It's just not possible. So what we're going to do is take a different approach. And there are two ways that we can solve this equation. So method 1 is going to use inverse operations. Right now we are raising the 5 to a power, and that's an exponential. So if you remember, though, the opposite or the inverse of exponentials are logarithms. Okay, so if you want to undo an exponent, you have to apply a log. So that's what we're going to do for method 1, is we're going to take the log of both sides. So I'm going to simply write log in front of 5 raised to the x minus 2 power. And I'm going to make that equal to log of what's on the right, which is just 200. So I've taken the log of both sides. So then the next thing I need to do is to recognize that here I have the log of a value with an exponent on it. And this exponent becomes the coefficient, if you remember your log properties. So applying that log property gives me now this equation, that x minus 2 times log of 5 is equal to log of 200. So remember, we're solving for x, so I need to remove everything off the side that is not x. And I'm going to start by dividing both sides by log of 5 to move it to the other side. So log 5 divided by log 5. And what I have left is x minus 2 is equal to log 200 divided by log 5. So this is going to just give us a value, so we will wait until the end to type that into our calculator to evaluate it. And we have one more step to get the variable isolated, and I need to add 2. Add 2, add 2. So our solution, let me scoot this up. Our solution is going to be, our value of x is going to be log 200 divided by log 5, and then we'll add a value of 2. Now, if you're using a scientific calculator, then you're going to need to calculate these individually, and then you can divide them and then add the 2. Or if you have Desmos or some other type of multi-lined calculating option, then you can type this in all at once. So I'm going to perform division. On the top, I have log of 200. I have log of 200 divided by log of 5. And to that, I will add a value of 2. So our solution is 5.292. So x equals 5.292. Now, this is method 1, and that is taking, see if I can zoom out a little bit, and that is taking the log of both sides. Now, method 2, and we're going to compare our answers in the end. Now, method 2 takes into account that every exponential expression can be rewritten as a logarithmic expression. Okay, so we want to, in method 2, rewrite the equation as a log equation. Now, what do I mean by that? If you remember from previous sections, we can rewrite this, making it log of whatever our base is, and we can use the value that the equation gives. So I'm going to take 5 raised to the x minus 2 power equal to 200, and I want to rewrite as a log equation. So I'm going to have log, and my base is base 5 of 200 is equal to, and remember, a log is just an exponent. So the exponent in this entire equation is the expression x minus 2. So we have rewritten this equation as a log equation. So now, well, how am I going to solve it? Well, my x is here. The only thing I need to do is to add the 2 to this side. So I'm going to add 2 on both sides of the equation. And I have log base 5 of 200 plus 2 is going to give me my solution. So that's what I'm going to type into my calculator. And we're going to see if we get the same answers we did before. That'll tell us if we did this correctly. So if your calculator does not have the ability to change the base, then you will have to use method 1. But if you can calculate in a base other than base 10, then you can use the second method. So I want to type in log, and this time I have a base of 5 of 200. And after that, I need to add 2. Our solutions here match. We have that our x value is equal to 5.292. Okay? And as always, if we want to check our work beyond this, we can plug this 5.292 into the original equation, and you can check it out. Now, at this time, I want to give you all three, additional problems for you to try and make sure that you get them correct. So here we have 3 raised to the 2x power equal to 27. We have 7 raised to the negative x power equal to 21. And lastly, 2 raised to the 3x power equal to 15. So the first problem is going to be like example number 1. The second and third problems you can do using our second examples. I suggest that you try one using each method to see which one you like better. So pause the video here, and then I'll come back with the answers. All right, so here is the work, and my answers are shown. Let me put a box around this one. So feel free to pause the video and make sure that your work corresponds to what I've done, or that our answers correspond if you chose a different method. And I have the checks there as well. So I hope that worked out for you. If not, feel free to send me an email or watch this video again and try it once more.